In 8.2, we're going to learn about how to multiply polynomials. And we're still going to work with the vocab terms polynomial and binomial. And to the right here, we have a visual representation of multiplying a monomial with a binomial. So this is the monomial x and the binomial 2x plus 3. A rectangle is given to you with width x and the length 2x plus 3. And obviously, this has an area of x squared plus x squared plus x plus x plus x. Okay, and by combining these variables, we get 2x squared plus 3x. Now let's look at a different way of finding the area of this rectangle by using the distributive property. So if this x is the width of this rectangle and 2x plus 3 is the length of the rectangle, then I can take x and multiply it by 2x plus 3. And then I'm going to distribute the x into the binomial 2x plus 3. So x times 2x gives you 2x squared. And x times positive 3 gives you positive 3x. As you can see, they're the same. Okay, now we're going to look at a more complex problem of where they want you to multiply a monomial with a polynomial, also using the distributive property. So here I have a monomial 2x cubed multiplied to a polynomial with 4 terms. So now I'm going to take 2x cubed and multiply it by x cubed. And then I'm going to take 2x cubed again and multiply by 3x squared. As you can see, I am showing all my work for now. And later on, you're going to become so good at this that you don't need to show your work. And then 2x cubed times negative 2x. And then 2x cubed again times positive 5. Okay? Now, to multiply these factors together, you should get 2 times x to the 6th power. The next one, 6x to the 5th power. And then 2 times 2 is 4. And remember this negative sign here because of this negative sign. And then x to the 4th power. And then 10 to the x cubed. And I can change this to a minus sign. Okay, and now let's practice another one by multiplying polynomials horizontally. So here you're given a binomial with a polynomial. So it's slightly more complex now. So we could take 4x and multiply by 2x squared. I'm going to take another 4x and multiply by positive 5x. And then again, 4x times negative 1. Now we're going to take the second term and distribute it as well. So negative 3 times 2x squared and negative 3 times 5x and one more, negative 3 times negative 1. Now this would be 8x cubed plus 20x squared followed by negative 4x. And then this one would be minus 6x squared minus 15x plus 3. And now we can combine our terms. So positive 20x squared with negative 6x squared makes 14x squared. But we can first write 8x cubed because there's no other terms with the variable x cubed. And then we can take that term, 8x cubed, and add 14x squared because of positive 20 minus 6. And then we can take negative 4x and subtract 15x, which makes negative 19x. And here we have positive 3 as your leftover constant. So now your expression is multiplied completely. Okay, now I'm going to teach you how to multiply binomials using the FOIL method. F stands for the first terms given two binomials. So 2x times 4x makes 8x squared. And then 2x times 1 gives you the outer. So O for outer. Okay, and then the next one, we have the inner. 3 times 4x, which makes 12x. And then we have the last. Positive 3 and positive 1, they are our last terms. So 3 times 1, 3. And then we can complete this, 8x squared plus 14x plus 3. And this completes our multiplying. Okay, now we can do some practice. I won't show as much work as before now. Now I see that I have a polynomial and a binomial. So I'm going to begin with the binomial and read backwards and begin with 4y. 4y times y squared makes 4y cubed. 4y times 8y gives me positive 32y squared. 4y times negative 6 gives me negative 24y. And now I'm going to look at negative 3. Negative 3 times y squared gives me negative 3y squared. And then negative 3 times positive 8y gives me negative 24y. And then negative 3 again times negative 6 gives me positive 18. And now I can combine like terms. Now 4y cubed stands alone, so I'm going to recopy that. And then I have a y squared with two terms. So 32 minus 3 gives me positive 29y squared. And then negative 24y with another negative 24y, that makes negative 48y. And with now I have a constant left over of positive 18. And then now I'm going to do the next one. So here we can use the FOIL method. Let's multiply the first terms, 48x squared. And then the outer, 4x times negative 7, negative 28x. And then the inner, negative 60x. And then the last, plus 35. And then we can combine the like terms in between, which is negative 88x. And for the next one, we have negative xy times x squared. So using the distributive property, we should get negative x cubed y, because we have a power of 1 here. And then again, negative xy times positive 2y. That gives us a negative 2xy squared. Okay. And for the next one, FOIL method, negative 5z squared times negative 2z squared. So that's positive 10z to the 4th power. And then negative 5z squared times positive 9 makes negative 45z squared. Negative 3 times negative 2z squared makes positive 6z squared. Negative 3 times positive 9 gives you negative 27. And then negative 45 plus 6 gives you negative 39 z squared, and then minus 27. Okay, and now we're going to learn how to simplify the expression again, involving more complex polynomials. So here we're multiplying, and then we're going to add, okay? So 2y cubed times 2y cubed is 4y to the 6th power. 2y cubed times negative 7w is negative 14w to the 4th power. 2y cubed times negative 1 gives you negative 2w cubed. And then we're going to add that to 5 times w cubed, because I distributed a w. I'm going to distribute the w again to get 2w squared. Now I'm going to combine like terms. So with 6, we only have 1. 4, we only have 1. 3, we have 2 of these, so we can combine these two. And 2, we only have 1. So 4w to the 6th power minus 14w to the 4th power plus 3w to the 3rd power plus 2w squared. Okay, now let's look at a geometry problem. Write a polynomial that represents the area of the shaded region. So first we need to write an expression that represents the entire area of the square. So x plus 6 times x plus 5. And then we need to subtract this entire area from the area of this triangle here. So we have the base, we have the height, which is also represented by the expression x plus 5. So the area of the triangle will be half times x plus 6 times x plus 5. And now we can simplify. So for the first part, this would be x squared plus 5x plus 6x plus 30 by the FOIL method. And the second part here, now let's not get rid of these parentheses yet. We have half x squared plus 5x plus 6x plus 30. Okay, these should be brackets. And now we can further simplify this. Okay, now we need to distribute the negative sign. I'm just showing extra steps here to be careful. So your final answer should be x squared minus half x squared, which is half x squared, and then 11x with this one, so we could take it out to the side. Take 22 over 2, which gives you 11. So if we work it out, that should be 11, still 11 over 2, okay? You should be able to do this part in your head. And then 30, let me backtrack a little bit. This should be subtraction. So it should be plus 15. And then the final answer. So when you are distributing here with the negative 1, please be careful. Don't forget to change your signs. I forgot to do it here. Okay? Okay, let's take a look at some word problems. You're designing a rectangular skateboard park on a lot that is on the corner of a city block. The park will have a walkway along 2 sides. So these are the walkways. The dimensions of the lot and the walkway are shown in the diagram. Write a polynomial that represents the area of the skateboard park. So first we need to find out the length of the park and the width. So if the given entire length of the skateboard park along with the walkway is 45, if we subtract x, then we will get the length of the skateboard park. And then here we're given the entire length of the skateboard park and the walkway. So if we subtract x, we can get the width of just the park itself. So in here, the area would then be represented by 45 minus x times 33 minus x. And now we can solve. So 1485, 45 times 33, subtract 45x, subtract 33x plus x squared. Okay? And then finally, minus 70x plus 1485. Okay, so this will be the polynomials. X squared minus 78x plus 1485. And then what is the area of the park if the walkway is 3 feet wide? So we can take 3 and substitute in this for x. This would be 9 minus 234 plus 1485, and this will give you 1,260 square feet. Okay, let's look at one complicated problem right now. During the period 1990 to 2002, the amount of money E in millions of dollars spent on sporting goods equipment in the U.S. and the percent P of this amount that is spent on exercise equipment can be modeled by the following polynomials. Okay, A says find the values of E and P when T equal to 0, meaning when it's 1990. So all I did was take 0 and I plugged it into all of these T's, and of course all of this would cancel out and your final answer would just be 14,439 and 9 cents. And the same would go for the second equation. So my answers for E and P are here. And for part B, it asks you what does the product E and P, E times P mean for when T equal to 0 in the context of this problem? Well, if E means millions of dollars as given in the problem, and P means percent of amount spent on exercise equipment, so we take the percent of amount spent on exercise equipment and multiply by the total amount in millions, then we would get the amount of millions spent on exercise equipment. So this is just very conceptual. And in part C, originally I was going to have you calculate, but because the numbers here are so ridiculous, I'm not going to make you calculate. Okay, so I would like you to describe how can you write an equation that models the amount of money spent in millions of dollars on exercise equipment as a function of the number of years since 1990. Well, you simply multiply the polynomial E and P. Okay, so you can practice this in chapter 8, practice C. So this will be a long process. You have to take the first polynomial and multiply every single coefficient. So negative 5.56 times negative 0.00002, and then negative 5.56 again to this coefficient, this one, and then this one, and then repeat the entire process with the second coefficient, which is very, very tedious. Okay, but you can do this in practice C. And part D will be quick. How much money was spent in the U.S. on exercise equipment in 1990? Since this is T equal to 0, so that's easy. When T equal to 0, I can just take this number, because when T equal to 0, every term is going to be canceled out. And the same goes with P. I could take So again, I could take this number and multiply it to this number. All right, and then so that therefore $14,439.09 times 0.126, and you would get $1,819.33 in 1990, and that would be the amount of money spent on exercise equipment alone of all the sporting good equipment purchased. So again, read this problem again and watch this part of the video again to try your best to understand what's going on. And this concludes this lesson.